Okay, so here's an interesting problem. It says to use spherical coordinates to find the volume of the region outside the cone, phi is equal to pi over 4, and inside the sphere, rho is equal to 10 cosine phi. Okay, so outside the cone, phi is equal to pi over 4. Okay, so let me make a quick sketch here. I'll make this sort of two-dimensional so that we can see what's going on here. So we have the sphere. Let me try that one more time. It's a little bit better. And the sphere is given as rho is equal to 10 cosine of phi. And what that means is when phi is 0, this is rho equals 10 up here. So so this is 0, 0, 10, which means the sphere is radius 5, centered at the point 0, 0, 5. Okay, so that's the sphere. The cone then is pi over 4, so that's your 45 degrees. So I think what they mean by outside the cone is this region in here, right? In other words, underneath the cone is outside the cone, right? So this is inside, this is outside. So effectively then, if this is phi equals 0, and that's inside the cone, right, all of this is inside the cone up until we get to pi over 4. So what we want is the region between pi over 4 and the xy plane, 90 degrees, is pi over 2. Right? So outside the cone would be from pi over 4 to pi over 2. Okay. And then rho, right? Rho starts at the origin, which is 0, 0, 0, right here. And we want to go from that to the outer edge of the sphere. So that's simply between rho equals 0 and rho is equal to 10 cosine of phi. Obviously, it depends on phi. If phi were less than pi over 4, rho would be bigger, and then rho sort of decreases as you get to pi over 2, in which case it would be 0 again. Right, so those are the bounds of the integrals, right? So we want the volume. So we'll think of it as a triple integral of 1 dv. And since we're going to use spherical coordinates, we'll just do the theta integral first. Now this is completely symmetric around the z-axis. So theta just goes from 0 to 2 pi, since we're going all the way around the z-axis here. Phi, we know, goes from pi over 4 to pi over 2. And then rho goes from 0 to 10 cosine phi. Right. So you just have to remember, in spherical coordinates, dv is rho squared sine phi, d rho, d phi, d theta. Right, so that is the quantity we're going to be integrating here. And let's just do sort of one step at a time. I'll do the inside integral first here, which is just rho squared So we'll do the phi integral next. Sine of phi. So when we integrate rho squared, we get 1/3 rho cubed. And our bounds are from phi equals 0, I'm sorry, from rho equals 0 to rho equals 10 cosine phi. Right. So that's going to be, I'll hold it up for a second here. That's the theta integral. So from pi over 4 to pi over 2 is the phi integral. The 1/3 is just a constant. That can come outside, maybe all the way outside. Okay. So we have a sine of phi, and then 10 cosine of phi cubed minus 0 cubed, which is 0. Right, so we have to cube the 10 and the cosine of phi. So 10 cubed is 1,000, and we can bring that all the way outside as well. So 1,000 over 3. And by the way, there's no dependence on theta here, so we could just do the theta integral separately. If there was, you know, something depending on theta here, we would have to do that next. So maybe we'll just hold off on that and still just do this integral here, which is cosine cubed of phi times the sine of phi d phi. Oops, I forgot the integral here, sorry. Pi over 4 to pi over 2. And then the d theta one. Okay, so my plan is to do this integral next. And that to me looks like a substitution, right? If u is cosine of phi, the derivative of cosine is just negative sine. So this would be our du. If there was a negative, well, that's not a problem. Just make it negative. Of course, I can't just multiply by -1 unless I multiply by -1 twice. So a negative times a negative is positive. So see what I did? I put the negative sign all the way out here. Right. So that gives us the negative 1,000 over 3 on the outside. Again, my temptation is just multiply by 2 pi here, but I'll hold off on that. So the integral then will be u cubed du. Now, again, u does not go from pi over 4 to pi over 2. It goes from the cosine of pi over 4, which is square root of 2 over 2, to the cosine of pi over 2, which is 0. And while that looks backwards, right, it looks like this will be negative, but that's just going to cancel the negative in front. So we'll see how that happens. This is negative 1,000 over 3. Let's just do this integral right now. From 0 to 2 pi minus 0 is 2 pi. All right, and then for the u integral, we're going to get 1/4 u to the 4th evaluated between square root of 2 over 2 and 0. Another way to write square root of 2 over 2, of course, is 1 over the square root of 2. Remember, at this point, we don't need to rationalize our denominators anymore. You know, you could, but you don't have to here. So let's see what we have here. We have negative 1,000 times 2 pi divided by 3 times 4. So that to me looks like negative 500 pi over 3. Right, 250 times 2, yep. and then 0 to the 4th, that's a 4, minus 1 over the square root of 2 to the 4th. And of course, that's just going to be 1/2 squared, which is 1/4. So negative 500 pi over 3 times negative 1/4. So we do get a positive, well, so 250, I guess 125 pi over 3. All right. So that looks like a volume. It is positive. And so the volume inside this little green region up here, right? Again, this is just a cross section. Just, revolve this around the z-axis. And it looks like we get a volume of 125 pi over 3. So I hope this helps.